Okay, finding unknown distances using the Pythagorean theorem. A little bit of a side note, definitely wasn't the first one to do it, but it's stuck in the textbooks forever, so we're stuck with it. For short, I'm just going to refer to this as Pythag because who wants to say more syllables when you can say less? Okay, so what is Pythagorean theorem? You already know this, but apparently a couple of you have either probably not totally forgotten it, just clunky in remembering. So long as I have some kind of right angle triangle, I can label my sides A, B, C typically. You can label them whatever you see fit. You can label them smiley, frowny, and angry if you want. I don't particularly care, that's up to you. No matter what happens, these two you could switch the names of, but your hypotenuse, your longest side, has to remain, in this case, C, or it has to remain the same whatever you're using. It doesn't matter which way you label the others, but once you label them, keep them whichever way you're going to label them. Cool. One of the most memorable things, a squared plus b squared equals c squared. Cool. This will only ever work if and only if, hence IFF, that's short for if and only if, you have a right angle triangle. Okay, so only for right angle triangles. Okie dokie. Nice easy warm up stuff. So, I have a right angle triangle, so I'm okay to use Pythag. I want to get that last side. Okie dokie then, I'm going to decide to call this A, I'm going to call this B. Could I have called this B and this A? Yeah, sure, why not? But this guy's going to have to be C. Beautiful, okay, so now I'm just going to chuck in good old, so 3 squared plus 4 squared equals x squared. Beautiful, alright, simplifying down, 9, 16, x squared, 25. Cool, I want something squared is 25, so I could take a square root on both sides, which would give me 5 is x. Beautiful, done. Isn't that boring and easy? Yes. So, why are we doing this? Because some of you seem to have forgotten particularly how to do that. So, let's do that. Alright, I'm going to do this the same way. I'm going to call this A, this B, this C. Okay, so I've got 12 squared plus x squared equals 20 squared. 12 squared, 144. 200 squared is 400. Okay, great. Well, now, going back to algebra day, so I want to get this by itself, so I've got to minus off 144 off both sides. Q, got x squared equals 256. Cool. You can chuck that into a calculator, so you're going to square root both sides. Maybe I should have done that up there. Square root, square root. Square root, square root. If you've done lots of them, you might know that's, 16. Cool, beautiful. Again, you can calculate off, so don't freak out too much about not knowing that one off by heart. Okay, so that's the basic gist of that. I'm pretty sure everyone will, after seeing this once or twice, they'll be like, oh yeah, right, I forgot. But there's another thing that less of you were familiar with. So I have a triangle here, but I don't know what angle this is. Okay, is there any way I can figure out what that angle is without using Trig? And the short answer is potentially. So I can chuck these in as though they were A, B, and C and see what happens. So I get 5 square plus 12 square equals 13 square. Okay, 25 plus 144 equals 169. Okay, add that in, gives me 169 equals 169. That's true, brilliant. Therefore, this is a right angle triangle. Fantastic. Now you might say, well, whoop-de-doo, I know it's a right angle triangle, so what? A lot of the time, particularly if you're measuring a room or something along those lines, it's really hard to actually measure measure angles accurately. So instead, you measure distances, because distances are pretty easy to measure accurately, and then you do a bit of Pythag and or Trig to figure out, hey, hang on, is this thing actually square? Square meaning 90 degrees. Cool, so this one's, that's nice, that's nicely built. We're happy about that. Okay, what about this guy? Is he nicely built? Well, let's find out. A, B, C. Highly recommend you label things always, just so you don't get lost in your own calculation or make a dum-dum. Cool, we've got 4, 9, 16. That's 13 equals 16. Well, that's a slight problem. That is not true, therefore not a right angle triangle. Beautiful. So whoever built this did a really crap job. That's the short answer of that. So that's all pretty easy. That's all 2D. 3D is another position where a lot of people start to come undone. something that I find is a very good idea if we're going to talk about something that's 3D when I've only got a 2D image of it. If I say, oh, that point, that's not particularly useful to anybody. So what we're going to do is start naming things. Call this A, B, C, D is that point. Yeah, we'll go here. E, F, G, H. So I've labelled the vertices or the corners of my cuboid box. Okie dokie. I want to get the longest length that's in here. So you could imagine this as like a wooden pencil case, like one of those old ones, where you like slide off the top, and then you get splinters all through your fingers. And I want to know, okay, what's the longest pencil I could possibly fit in here? Okie dokie. Well, after a little bit of thought, hopefully you would go, well, hang on, if I lay them flat, that'd just be 4. Okay, but I don't have to lay them flat. I could lay them at an angle. Okay, well, the angle might go from A to F. But then if I think about it a bit more, I'm like, hang on, what if I just spin that around a bit so I go from A to G? That's the longest possible distance I could possibly get. So, our end goal is AG, and that line just means the distance that they are apart. Okay, well, how are we going to get that there? Well, we could cut this thing into multiple 2D triangles, because we know how to deal with that, and then fiddle around with those 2D triangles to get this 3-dimensional result. Okie dokie. Well, what are we going to do first? I'm going to suggest that we do A to F first, and then after that we go to our actual goal, which is A to G. Now it's really hard to tell that there's much of a difference there. A to F is close to us, A to G is going into the board. So we're going to be a little bit careful. The shadow of A to G, so if I shone a light through that pencil, the shadow of that pencil would go between A and H. So if I'm shining it from directly above, I've got A and G, right? The shadow would come straight down, so it'd go A to H would be the shadow. Beautiful, okay? If I did the same thing to the red, well, it's already against the side of the box, so its shadow is this line here, the 4 line. Cool, all right, well, this diagram's getting really busy. A good idea at this point, split it out, draw separate, simple diagrams. So I've got one diagram where I've got a bar, where that was A, this was E, this was F, and separately, I've got the ... between A and H, the solid purple that way, the solid black that way, that's G. Okay, fantastic. All right, well, I want to know some of these numbers. Okay, in order to get that purple one, because that's my goal, I'm going to need both of these. Well, do I have G to H? Yeah, I do, that's 2. Okay, that's easy. Do I have A to H? Oh, no, I don't. All right, well, that's a problem. I've just realised the other thing that I've done, which was foolish. In fact, that's not the triangle I want. Good job, man. All right, fix that up. I wanted... Oh, I didn't dot it. Forget the red. Sorry about that. Good job, man. Alright. Yeah, okay, that dotted purple line. Dot. There are a couple different ways that you can do this, but I'll try to make this as neat as possible in the drawings. And the other one, start with the solid and the dot. Dookie, this was A, G, H. Sorry about that. Okay, so I want the solid purple, but in order to get the solid purple, I've got this 2, I'd need this dotted purple to use Pythag on these to get the 3rd. Alright, well, to get this dotted purple, I could draw this triangle. I know that's a 4, I know that's a 3. Okie dokie. Oh, let's start labelling these off. That'll be A, that'll be B. So I've got 3 squared plus 4 squared equals. Now, I'm going to give this a name. I will call this X, as I can. You can call it whatever you want, doesn't really matter. 9 plus 16 equals X squared. 25 equals X squared. 5 equals X. Fantastic. Cool, so from there, that was the dotted line X, so that's X there. Well, I can't call this X as well, so go to the next letter, Y. Well, we know X is 5. Okay, we'll call this A, we'll call this B. Now it doesn't matter that I've used A twice, well now I'm talking about separate triangles, so that's okay. But X and Y I want to keep the same in every example because I'm moving between different triangles. Okay, so I've got 2 squared plus X squared equals Y squared. Well, 2 squared was 4, X we knew was 5, so 5 squared would be 25. Y we don't know, that's the whole point, we're trying to figure that out. So 29 equals Y squared. Take square root both sides. Root 29 equals Y. Does that simplify? No, we've got a prime, we're stuffed. So it's root 29, whatever dimensions we're in, probably centimetres, forget the numbers, maybe inches. So root 29 inches, you could get a decimal approximate on your calculator, but that's as good as it gets. I am going to highly recommend you keep everything in exact because that will save you a lot of heartache later when you have to eventually do that anyway. You can always convert exact into approximate. It's really hard to get approximate into exact. Okay, one more annoying thing because it's more fun. So I've got this. I've got a solid square-based pyramid. Fantastic. I want to measure the height of this thing. Now you might just say, all right, well just stand here and measure the height. What are you doing? Well, there's a slight problem with that. If I'm measuring a height directly this way, it's really hard to figure out if I've actually measured it correctly or if I'm slightly above or slightly below. So instead, I measure the solid object because I can measure that accurately. Turns out we've got 10 by 10 for the square base, and this slanted side is 15. Okay, my end goal, I'm going to do in purple again, is the height which would go to the middle of the base. Okay, so goal is, well, I should probably give these things some names. Okie dokie, we'll give this A, B, C, D, call that E. Alright, what am I going to call this? I'm going to call this M for the middle of the bottom bit. Call it whatever you want, doesn't matter. These don't have to be A, B, C, D. You can call them whatever you want. Don't call them numbers because you'll confuse yourself terribly, but any sort of symbol should be fine. So I want to find the distance EM or ME. It doesn't matter if you measure it upside down or which way because it's still the same distance. Okie dokie, well, how can I get that? Well, after a little bit of thinking, we might go, oh, if I knew what this distance was, I would have the following triangle. Regular one, and black. So I would have EMC, 15 there. Don't know this, I want to know that. Okay, so now I just need to get that red distance. Well, how am I going to get that? Well, if I think about red plus green, and then these two sides, we can go dot 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 with the green, dot 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 with the red. These two sides, so we've got A, C, D. 10 and 10, great, I can figure that out. And since we know that this is a square base, we know that that middle bit is literally the middle of those two, so green and red must be equal. Beautiful. Alright, let's give these things some variable names. Alright, I will call this, call it in pink, call that whole thing X. Keep in mind that this side would therefore be X on 2, because it's only half of the full X. And we'll call this Y. Beautiful. Okie dokie. Let's do some mathematic. Doesn't matter which one I call A and B. I'm going to do it that way this time because why not? I'm a rebel. Plus 10 squared equals X squared. Oh, equals, not plus. Cool. That's 100 and another 100 equals X squared. So I've got 200 equals X squared. Take square root. So I've got square root 200 equals X equals X. Now, we could go through the process of saying, oh, okay, that's the same as that third, but it's not going to matter in a second, because we've got this guy. What's the first thing we're going to do? Well, actually, it's probably actually a better idea in this case to do that, but it doesn't matter. Cool, what have we got here? Well, if we call these some names, I'll call this A, this B, this C. I've got X on 2 squared plus Y squared equals 15 squared. Okie dokie. X squared, well, X was root 200, so if I square it, that'll just be 200. Over 2 squared would be 4, plus Y squared, don't know, that's kind of the point. 15 squared, 225. Yeah. Beautiful. Okay, well, 200 divided by 4, that's 50. Cool. Alright, we want to get y by itself, so move that 50 out of the way. Y squared equals 175. Y equal, oh, whoops, should have written. Take the root. Root 175. Beautiful, so we've got an exact answer. We could simplify that further with surds. Notice that this thing divides by 25. We've got 7 lots of 25 in there, so that's 5 root 7. Beautiful. And again, you could convert that into a decimal approximation if you want, but always do exact and then go to approximate afterwards if need be. Never go to approximate straight from the get-go, because if you need it exact, you're stuffed because it's hard to go backwards. Beautiful, that's 6b, that's a really quick reminder. I imagine that you're familiar with this somewhere and it just didn't come out in the pre, so this is just a reminder. Beautiful, something to look out for everybody. No, I'll do that in the meeting, so that's fine. So that's that. If you've got any questions or anything, email me as you need. Otherwise, cheerio.